In this video, we will introduce inequalities. Inequalities use one of these symbols. Both of these are greater than, but if they have that equality, that little line underneath it, that means that not only is it greater than, but it's also equal to. These two are less than, and again, if it has this little line underneath it, not only is it a less than, but it's also an equal to. Solutions to inequalities are not single values like we've done in the past when we were solving equations. It can be a range of values given in the form of interval notation. So this is what it means. Sometimes your solution is going to be all the numbers greater than a particular value, but they don't include that value. So that's what this symbol means. X is greater than that number. When you have all the numbers are less than a value but do not include the value, then we'll use this. Thus, x is less than that particular value. Now, if your solution is a number greater than a particular value, but you do want to include the value, then we will use a greater than, but we will include that little line. If it's less than a value, including that value, then we'll use the less than, but we put a little line. Let's say then your solution is between two values, two numbers, but you don't want to include the values, then this is how we write our solution. X is between A and B. A is less than X, less than B. If you do want to include one of the values, then you will have to write that little line underneath it. So this one says that X is between A and B, but you do include A and not B. This one states that X is between A and B, but you don't include A and you do include B. And also, X is between A and B and you include both values. If you want to state that your solution is less than a particular number or greater than another value, then we will write it like inequality like this. If you mean to say that the solution is all real numbers, that means that every single number will work as a solution, then we say that X is an element of the real numbers. To help us move from the inequality notation to the interval notation, we might have to seek help from a number line. So let's see how this number line will help us to move from the inequality to the interval notation. This right here, X is greater than A. Well, in a number line, that will mean that you want any number greater than A. Anything is going in this direction all the way to positive infinity, but you don't want to include A. There are two different ways that you can do that. There's some books that use an open circle to state that it doesn't include the number. Let's write it up here. And there are other books that use parentheses to say that they do not include the value. We're going to be using parentheses instead of the open circle. And the reason for that is to help us with the interval notation. So since this one means that you want all the numbers greater than A but not including A, we are shading all the way from A to positive infinity, but we're not including A, so we put a parentheses. So that's what this one means, that you want all the values from A all the way to infinity, but you don't want to include A, so we place a parentheses. Make sure that you know that infinity will always take parentheses regardless if you are or you are not including the number. Let's try another example. Let's say that this time you want to move from this inequality from X is less than or equal to B. That means that you want all the numbers less than B including B, and we want to move into the interval notation. So let's use the number line. So I want all the numbers less than B, I'm shading to the left, all the way to negative infinity, but this time we do want to include B. In some books, they use a closed circle to mean that you do include the number. Other books use the square bracket to say that we do include the number. We are going to use the square bracket to help us with the interval notation. Since we are shading to the left, I'm going to use this square bracket. So if you notice, we're shading from left to right, from negative infinity to b. So then the interval notation will be negative infinity to b. Since we are including b, the b will take a square bracket, but again, the infinity will always take a parentheses. An infinity will never take a square bracket. Let's try one more example. Let's say that we want the interval notation of this inequality. That means that I want all the numbers between a and b, and this time I only want to include a. So then I shade from a and b. Since I am including a will take a bracket, and we know we are including because it has this little line down here. But since b doesn't have the equality line, that means that I'm not including b, so then b will take a parentheses. So then the number line is being shaded from left to right, from a to b, including a and not including b. And that's exactly what the interval notation looks like. We're shading from a to b, a square bracket on a because we are including a because of that little line, and a parenthesis on b because we are not including b, since b doesn't have a little line underneath. Then we are ready to move on to example 1. Aside from knowing how to move from the inequality notation to the interval notation, we will be using the following properties of inequalities. The addition property states that if you have an inequality, it doesn't matter if it's less than or equal to, greater than or equal to. But if you have an inequality, we are allowed to add a value on the left as long as we add a value to the right. Now that value doesn't necessarily have to be positive. The value could be positive or negative, and we will keep the inequality. The multiplication property states that if you have an inequality and you have this c value that is greater than 0, it means that it's positive, you are allowed to multiply the left side as long as you multiply the same value on the right side, and it will not change the inequality. Now, this property, this multiplication property, also applies to division. Instead of multiplication, if you want to divide, as long as what you do to the left, you do to the right, it will not change the inequality. However, if you have an inequality and this c value is less than 0, that's a negative. If we multiply the left, we must also multiply the right by that same value. But since c is negative, look at what happens to the inequality. It goes from a less than to a greater than. The same thing will happen if it was a greater than. It will flip into a less than. So then the way that we're going to remember this is the following. When we multiply or divide by a negative value, we're going to flip the inequality. Now, this only happens if we are multiplying or dividing by a negative value. If we are adding or subtracting, or if we are multiplying by a positive value, then the inequality does not change. So let's try this here. It says graph the inequality and give the solution in interval notation. Let's start with 1a. 1a reads, x is less than 2. That means that I want all the numbers less than 2, but since it doesn't have that little line underneath, I do not include 2. If I use the number line, I go to 2. Here's 2. I want all the numbers less than 2 in this direction, all the way to negative infinity, but I do not include 2. So then I'm going to place a parentheses. Our solution then, we write it by reading this number line from left to right. So our solution goes from the left, from negative infinity, all the way to the right. Well, the last number being shaded is 2, but since it does not include 2, remember, I'm going to put a parentheses, and then the infinity symbol always takes a parentheses. So then this is our solution. Let's try another one. This one reads, y is greater than or equal to -1. What that means for us then is that we want, right here, all numbers greater than -1. But because it has this little line underneath it, I do include the -1. I find my -1 right here. I want all the numbers greater than that. That means that I'm going to move on all the way to positive infinity. Since I do include the -1, I'm going to place the -1 with a bracket. So then my solution will go, remember we read the number line from left to right. It starts at -1. It goes all the way to infinity. Since we are including -1, we put a square bracket. And again, infinity always takes a parenthesis. And this becomes the solution. If at any point in time you have difficulties knowing if this is a less than or a greater than, I'm going to show you what I usually use. The less than symbol looks something like this. It kind of looks like an L. So then I can write the word less using that symbol. That's how I remember that this symbol means less. The other way that I try to remember it is using the number line. You see this arrow here? That arrow looks like a less than. So then if I see a less than, I shade in this direction. The arrow on the other side looks like a greater than. So then if I see a greater than, I shade in the direction of that arrow. Now this method though, the one the shading according to the arrows, only works if your variable, if your x or your y or whichever letter they're giving you is on the left side of the inequality. Thank you so much for watching, and I'll see you in the next one.